Hello, welcome to NPTEL course on finite element method. So, this course will be jointly shared by myself Bishwanath Banerjee and Professor Amit Shaw, who is my colleague at the Civil Engineering Department IIT Kharagpur. So, this course is an introductory course. Basically, it is meant for fourth year undergraduate student, those who have done structural analysis or the analysis of structure or mechanical components, and also a PG level course where first year MTech student can also take this course. Now, the requisite background for this course is applied elasticity and numerical methods. So, in order to start, or what is finite element method, let us think of a simple problem, right. So, in the problem you can see that any physical system essentially modeled or mathematically modeled through a differential equation or its energy approach, right. So, now when we try to solve this system, for instance, those who have done structural analysis course, we have solved beam problem, and those who have done MTech in plate analysis, those plate problems, those are very simple problems. Now, when you go for a complicated realistic problem, you really do not have any analytical results, or sometimes also known as the exact results of the system. So, we need some tool which we can use to approximate or to get essentially a numerical solution of the system through some method. One of such method probably some of you have learned is the finite difference technique, which is essentially a grid based technique, is a collocative type of technique, which probably you have used in your BTech or MTech. Now, finite element method essentially is a numerical method. It is so some of us have conception that finite element is related to civil engineering or mechanical engineering, but or any other particular branches of engineering, but essentially it is a numerical method. Finite element can be used even in electromagnetics or even in optics. So, essentially finite element, likewise any other numerical method, is a numerical method for approximation. Or what is that approximation? What we are trying to approximate? The approximation is essentially the mathematical model of the physical system. For instance, if you see this picture, then you will see that there is a dam which we first idealize, or the computational idealization we do. For instance, here we have done it on the 2D plane strain domain. You can easily approximate as a 2D plane strain domain. Now, this mathematical model for this problem is essentially the differential equation on the this side. Now, this del dot sigma equals to B is the governing equation, including the boundary condition, that is traction boundary condition or stress boundary condition, and then the displacement or the kinematic boundary condition. Now, the where finite element comes? Finite element comes to solve this problem numerically, because if you look carefully that these dams we really cannot solve, or we can essentially do a 3D dam problem also, we really cannot solve it exactly. So, we need some numerical technique to solve or to get the solution of the system. Now, in finite element, there are this course is all about the introductory part. So, there are several advanced finite element technique is there. So, obviously, we will not go for those techniques in this course, and finite element, if you go to the history of finite element, then finite element is the most popular and the oldest method of numerical approximation till today. So, now finite element, what it was 50 years back and now is entirely some parts are really same and some parts have really modified. So, and you will be surprised to know finite element has been invented by the engineers first, then the mathematicians have jumped into it and finally proved its convergence and other things. So, basically our course, what we will follow is this. So, first week we will introduce or briefly summarize the requisite knowledge or the required knowledge for this course, and then in the second week we will essentially try to learn or try to do some basics of calculus of variation, which is a building block for finite element solutions, and finite element formulation will cover in the next week, and then specially the approximate solutions of 3D elasticity like beams, and then that we will cover in 4 and 5 week number 4 and 5, and then we will cover plane stress problem, plane strain problem, essentially 2D problem. But before that we will also do some truss problem and frames, and then we will also discuss some issues related to finite element technique, and then we will finally move to 3D continua. Now, before I close, I wanted to highlight one important thing here, that this course is basically a theoretical course, but focus will be based on the application or the application domain, and the application domain for this course will be mainly the structural engineering or the mechanical engineering, the involving solid bodies. So, finite element can be applied to heat treatment, thermal problem or the heat treatment problem or the fluid problem. We will not cover those things in this course, and moreover that finite element that we will be doing here will also highlight or will stress how to code this theoretical background or how to convert this theoretical background to a really applied thing or in terms of coding and other plotting and other things. So, pre-processing, post-processing will also use, in some cases we will also use this problem. Moreover, this course will be shared with Professor Amit Shaw, who is my colleague at IIT Kharagpur, and I request Professor Shaw to tell something about this course.
Yeah, that's fine. Professor Banerjee has already mentioned what is the objective of the course and the structure of the course. So, we look forward to see you in the coming semester. Bye.
Thank you.
Thank you.